right, so let's look at 11a. Find K and the points of contact if the parabola touches a quartic at 2 points. All right, it only touches it at 2 points. And when we put these two together, so they touch or intersect, so when we put them together, we get x to the 4 equals x squared minus k, or x to the 4 minus x squared plus k equals 0. So we could be looking for 4 roots if they were single roots, if they cut through. But this is touches, so tangents at 2 points. So it's like we've got 4 roots, but they're alpha, alpha, and beta, beta. So we've got double roots. So you can imagine if I was graphing this quartic here, and I know it's got double roots, so it's happy. So that means it bounces and bounces again. So it looks something like that. So you can see that at these points where I'm talking about the double roots, they are also stationary points. So it's a bit hard because we haven't done this bit yet, but they're also stationary points. Stationary points we know can be found when the gradient of the tangent at that point is horizontal, so is equal to 0. So if we find the gradient by differentiating and set it to 0, and we'll just factorize that. So that's wrong. There we go. That's more correct. Yes. All right. And then, so we can see either x is going to be 0, or x is going to be, or x squared is going to equal a half. So x has got to be plus or minus 1 on root 2. All right. And now it's a double root, and you can see that what works for us is if we have, let's put our y here. So we are going to have a stationary point, 3 stationary points, right, for this quartic. So clearly the one in between is the one up here. See, there's another stationary point there. So that's going to be 0. So this is going to be 1 on root 2, and this is going to be negative 1 on root 2. So that's where they're going to occur. Now, that means that, what does that mean? If we want to find K and the points of contact, so that means that X equals 1 on root 2 at that point. So, or negative 1 on root 2. So if I put that in this equation, we should be able to find K, right? So, because they're the roots of the equation, double roots of the equation. So you can see I'm going to have 1 on, so if I do it to the power of 4, it doesn't matter if it's plus or minus because it's to even powers here, power of 4 and power of 2. So root 2 times root 2 is 2, and 2 2's are 4. Root 2 times root 2 is 2. So I'm going to get K is negative 1/4. Positive 1/4. So 1/4, take away 2/4 is negative 1/4, but if I put it on the other side, it's positive 1/4. So K is going to be positive 1/4. So we're actually looking at the quadratic and the quartic, and they are going to touch each other when our x equals plus minus 1 on root 2, both of those. So the point T of contact, if that, the points of contact, sorry, I'm reading below. So the points of contact, well, let's have a look. If I put, which is easier, maybe this one. If I put x equals 1 on root 2 in, we already know I get 1 on 4. Is that right? So my x value is going to be 1 on root 2, my y value 1 on 4, or my other point of contact is minus 1 on root 2, 1 on 4. Of course, if you want to rationalise that, you can rationalise that and make that root 2 on 2 instead of 1 on root 2.